Yeah, we'll just allow a few more people to join us. And yes, hello, good afternoon. I know it becomes harder and harder as we progress through the conference. And I thank you for joining us. Today I'll talk about .NET applications on AWS, which sounds a bit off. Before that, my name is Dror Helper, really my name. And I'm a Microsoft specialist working at AWS. So my job is to work with customers to move their AWS infrastructure and code to the AWS Cloud. Things like Active Directory, SQL Server, .NET. We talk a lot about modernization. We might get to that today. But before that, we'll talk about what it means to write code in .NET that will use the AWS Cloud. And of course, so how can we use the AWS Cloud with .NET? Let's start with why should we use the AWS Cloud with .NET? Because it sounds a bit different. Anyone here use AWS? Right. Everyone here writes software, right? .NET developers, raise your hand. Who writes .NET Framework? The old. Okay, so everybody uses the latest and greatest, right? So what do we want when we want to write code with .NET for AWS? We want to use our development environment, right? Who uses Visual Studio? Anyone uses something that is not Visual Studio? Code? Rider, right. We'll talk about Rider. We want to be able to call services from our code. That's the second thing we need. And we want the ability to continue working as we were without anything hurting us easily, again, by using .NET. So, first of all, AWS is investing on Microsoft workloads and .NET for the last 13 years or more. In fact, AWS is one of the leading infrastructure providers for Microsoft workloads. We've been running Windows before several of the other providers even existed. And as we move along, more and more things come out. In the beginning, it was mostly virtual machines running Windows and then SQL servers. And as you go up the graph, you'll notice something, the color changes. It changes from orange, which is infrastructure, to, in this case, white and green. And white is .NET, it's things specifically for .NET developers, and green is things specifically for .NET modernization. And you can tell that those two colors dominate as we go up. We still have virtual machines with Windows, but it's not that interesting anymore. It's more interesting how we can make developers' lives easier, because AWS actually likes .NET. In fact, we are a major part of the .NET Foundation. The .NET Foundation is responsible for .NET, or the newest runtime, and as well as other open source projects. And AWS is one of the key partners there. We contribute time and people in order to advance several of the .NET open source libraries, because our customers are there and we want to be there with them. So having said that, what can we do with .NET? If you want to start using AWS with .NET, the first thing you'll need is an AWS account. But once you have that, you'll want to install one of the IDE toolkit we have. We have toolkits for Visual Studio Code, and JetBrains Rider that will enable you to quickly start implementing and prototyping things on AWS. You will get a bunch of tool windows that you can use. Okay. You can, from which you can do common things developers need to do with the AWS infrastructure. You want to create a new table. You want to see files stored on AWS on S3. S3 is the file storage, the blob storage in AWS. You want to check your users. You can do all of that from within Visual Studio or any other .NET IDE you're using. Instead of going to your browser, opening the AWS console, and context switching between two different environments, you can do everything from your Visual Studio. Obviously, it's not all of the capabilities of all the services, just the ones that developers use when they start to write an application. Want to check things. Want to check if your Lambda function is there, if your logs stored, Or if you have a new table, you can do that from Visual Studio. Second thing, you get a bunch of templates around specifically AWS Lambda. I'll talk about that. That's serverless function in the cloud that will enable you to create around Lambdas around very specific use cases. And the last thing you get is a deployment tool. This is the old one. There's a new one for .NET, which was used to call .NET Core specifically, that enable you to deploy to various targets in AWS, from a Beanstalk virtual machine in a managed solution, all the way to Lambda functions, or a cluster of Docker images running somewhere in AWS. Once you have that, you can start using AWS in your day-to-day development. But what does it mean using AWS? Well, you want to write code that will use different services. And for that, you want to use the AWS SDK. The AWS SDK is the client libraries you can use to write or read things from AWS Cloud, from different services. All of them start with AWS SDK.something. AWS SDK.S3, for example, will enable you to perform operations with S3. AWS SDK.DynamoDB will do the same with Amazon's key value non-relational database. All of those are in NuGet, so nothing new here, right? That's how we consume .NET libraries. You go to NuGet, look for AWS SDK. The service you want to use, and you can start using it. It will provide you APIs directly to the services and higher level functions, utilities that you can use on top of those services. And finally, those higher level functions will reduce the amount of code you need to write. For example, if you want to transfer file in chunks in an optimized manner, you can write that code. Or you can use the AWS SDK with transfer utility. If you want to cache secrets you have on the cloud, so you don't need to go back and forth every time you need to read a value, you can do that or use a caching mechanism. And same for many other capabilities. It's cross-platform, which means work with .NET Framework, .NET, Unity, you name it. Xamarin, if you can find it. All of those are supported with the AWS SDK, unified API. And finally, it's open source. If you go to NuGet and write AWS SDK, you can see the code. There's no secret there. It's not code you couldn't write yourself. Basically, a bunch of HTTP calls going back and forth. But you don't need to do that. Now, the AWS SDK is very simple to use, and once you've seen one, you've seen them all. This is, for example, a simple function that calls S3, get and then list all the files stored in that file storage. So first you need to create a client. Here we go. I'll create a new AWS client. There's a bunch of constructors according to the different operations. Also, usually on my dev machine, I have a bunch of configuration stored in my machine because, for example, my credentials are not in my code. That's not best practice. Instead, it pulls the credentials I configured in my code. And then once I have a client, I can press dot and choose the operation I want. In this case, list all the objects. Now, you might have noticed it's a synchronous operation. All the SDK in .NET is asynchronous. Everything is with await async. I don't think there's much. You don't really want to write any other blocking code otherwise. And you have a request object with all the parameters that that operation needs, and a response object you can then run along and use. Let's say a different example. Here in Visual Studio, I have a simple method. I created a class in order to pull information, items out of a queue. SQS is Amazon Simple Queue Service. In Amazon, the naming is a bit confusing for someone just starting, especially with the older services. SQS is the first service AWS ever created. And with Amazon, just remember it's always either simple or elastic. So simple queuing service enable me to send and get information in a persistent way, highly available and very cheap. So in this case, I'll create an SQS client somewhere outside of this class, and I'll get a queue name. And if the queue does not exist, then I'll create a new queue. And the code to do that, go to implementation, is very simple. I'll take the client, I'll list all the queues, and then I can write simple link query and check whether I have the queue URL and whether or not it existed. And if it exists, return it as a string. If not, then I'll get null. And it's as simple as that. Same for creating a new queue. Create a queue request. That's the object I need to set up with the queue name, all the attributes I need. That's a lot of them, but I don't need all of them. And then I'll call create queue async, and with that in specific request and get a result. And I can see the other operations just like any other code, using auto-completion. So I've created a queue if it does not exist. And once I have the queue, I'll get the next message, create a request object. I want just one message. And then I'll tell it to receive a message. It will block until the timeout happens or I get that message. If there's no messages, continue. Otherwise, get the message body and return it as a string. Using the AWS SDK, I can perform multiple operations depending on what I'm going to use this way. So that's the SDK, but I am sure most of you do not write console applications for a living, right? Maybe from time to time, but usually these days we're using .NET Core, ASP.NET Core microservices, right? I hope. So with microservices, that service should run somewhere. We'll get to that. But that service can use different AWS services in order to perform its operations. For example, configuration can be stored in AWS parameter store, where it can be stored either as plain text or encrypted. Or if you want to use different encryption keys, or you want to replace your password every now and then you can use AWS Secrets Manager, both of which have integration with ASP.NET that you can use. So you can hold all your secrets, all your data that is changed between different environments somewhere else, not inside your code. You can use places to store information. Now, if you're using databases, regardless where they sit, you have a connection string. But with AWS, you can also use, like I shown you, AWS S3 stands for Simple Storage Service, S3, and where you can store files. Or I can use Amazon DynamoDB, which is a database I can use in the cloud. And finally, communication between microservices shouldn't be always just using HTTP calls, synchronous HTTP calls. I can also use queuing with SQS or pub/sub, publish subscribe, to multiple places, other services as well, using the AWS Amazon SNS. All of those you call from using the AWS SDK. But in case of .NET, ASP.NET Core, you can do more. For example, we have an extension you can add to your project, and then all your configuration will be pulled directly to your AWS service, both from your application settings file, where you can add AWS-specific configuration, and then you can set it up or pull it, and directly from the AWS Cloud in your production environment or staging environment. The second thing we can do, instead of initializing clients all over my code, I want to use dependency injection because that's the right way to do things. So I don't need to initialize a client. I just need to use, again, another NuGet package, and then just say add AWS service. That's an extension method we added, and the name of the service client or interface. So in this case, I'm automatically creating dependency injection according to the configuration that was pulled from using Microsoft configuration, either a file, AWS, or somewhere else. And I'll create an S3 client, a DynamoDB client, which then will be automatically injected through constructors or properties to my code using ASP.NET built-in dependency injection. Now, a service will look something like this. Yeah, I tried to keep it large enough. I hope you can see it in the back. If not, just please tell me. So here I have a task service. This is a simple service that will create and read tasks. And going into my program CS file, you can see that I'll do all the regular stuff, add controller, API, Swagger, right? Everybody did that? Someone? I see nods, okay. And then I want to take out the AWS options. This is configuration specific to AWS, coming through the configuration I just created for this. I'll take the region out, set a different region, and then store those options in my code. And here I'll create an Amazon S3 client, and going back to the regular ASP.NET configuration. Now, the trick with this service is that instead of using the database for my backend, my repository, in fact, is a repository based on S3. So it will automatically get the client. And if I want to list all the tasks, it will just list all the files in S3. And if I want to get a specific task by ID, that's the file name I've created. I'll create a request with the file ID as the key and read the information. I can even create new task. Let's see it running. Nothing yet. There we go. That's not what. There we go. So here is my Swagger for my service. I'm a backend developer originally, so no nice API and no client here. And Microsoft go away. And if I want to see all the tasks, I can just run it. If I execute it now, it will just in time compile. And hopefully, in a second, we'll get that information. I'm not sure how good is the internet here, so let's hope. Okay. That looks to be, oh, here we go. There's a single task. It has this ID, it has a title, and it has some content. Let's create a new task just to see it working. I'll try it out. Title. And the content is one. And a new task was created. If I'll go to the AWS console and look at S3 and increase the font size a bit, between those are the different buckets, the different containers. So I can say I have two tasks here, the one we saw before and the new one. Those are two files that were, the second one was just created with all the information I sent in. And I was able to do that with 5 to 10 lines of code. So that way I can read and write things from AWS. I can do the same with other services, obviously. This is just a simple way to do that. And that service which I just created should be hosted somewhere, probably using Docker. Now with AWS, I have two different APIs .NET developers can use. Can you tell the difference? I'm sure you never saw both of them. Can you tell the difference between the left side, your left, which is the SDK? That one send a new message request using a queue. That's this side over here. To the right one, the one on the right. Can you guess what it does? Sorry? In a way, it does. It does not show a message to the user, but because it does something that we don't really expect to do as .NET developers. The right side is setting the infrastructure that is needed in order for the left side to work. This is AWS CDK. CDK stands for Cloud Development Kit. Usually in the cloud, we either build things by hand, set up all the services I want, use other tools like Terraform or in AWS CloudFormation, but developers can use code. We can write code in C#, Go, Java, Python, and TypeScript that will set up my environment. And that code then can be used to set up multiple environments exactly the same way. Can be stored in source control. This is infrastructure as code. And we can use C# for that as well. That's what I usually do if I can. And AWS CDK enables me to tell AWS what I want to create in AWS. That's not the code running. That's the thing that will run before the code can run. That's usually in my build system. I'll have a build specifically to change my infrastructure. The CDK is a tool that once it runs with this code, it will create the instruction needed in order for AWS to build those. So what do we see here? In the beginning, yes, it is a user. I'll create a user, actual credentials. I need that user because every service needs to be able to call other services. So once I create that user, and I can tell the queue, anyone that uses that specific credentials, that specific user, can call that queue. And again, I can do that by code using references and not by writing JSON, YAML files, which are a bit slightly harder to read. So I created a user, I've created a queue, and I told AWS that user can use that queue. Later on, I'll use that user in my service in order for the service to be able to read or write things to that queue. In this case, I allow that service to send a message. The code on the left will not work if I don't configure something. Nothing at all. You can have multiple times the same thing. Also, CDK is geared toward developers in a way that I don't need to specify everything. If you ever written scripts to set up any cloud infrastructure, there's quite a lot of properties to set up. With CDK, it's a lot around the defaults. So I don't need to write everything, just the things I care about. The rest will be auto-filled. If I write twice, well, it depends what the message is. In this case, nothing happens. It does not create a script that will crash. I can do that. It's harder to do with CDK because it tries to help me not do those kind of mistakes. And here I'll also create a topic. A topic is a publish subscribed kind of engagement. Someone sends a message being multiplex sent to multiple subscribers. In this case, I tell that topic, you have a new guy that you need to send that message. It's that queue. And the rest of the infrastructure, this roughly 5 lines, well, I'm cheating. The user takes 3 lines. I didn't want to add that. But those less than 10 lines of code will translate to 100 or more lines of CloudFormation script in order to set that environment. Now, as .NET developer, I prefer that this way. I can read it, I can write it, I can store it in my source control, I can deploy it using my continuous integration. And I don't need to go into the AWS console, start building things by hand. Moving to AWS Lambda. Anyone here ever used Azure Functions? Raise your hand so I know. Okay, 1, 2. So what the idea with AWS Lambda? AWS Lambda basically says, as a developer, I don't really care about virtual machines or any infrastructure whatsoever. I just want to write code that will run. Now, AWS Lambda came out first in 2014, so the 10th birthday is coming up next year. The idea behind it is that if you have a relatively short running application, things that run 15 minutes or less, when you think about it, most of our applications today are 2 minutes or less. When I call an HTTP call, I expect to get that answer in 2 minutes or less usually. But 15 minutes or less, and it's triggered by something. It's event-driven. It can be triggered by HTTP calls, a file being stored in some other AWS service, someone calling it through the AWS SDK. There are a bunch of different ways to trigger an AWS Lambda. You'll get an event, your code will run, and then it'll stop working. And you can use this C#. Officially supported right now C# 3.1, .NET Core 3.1, and .NET 6. We always support the long-term supported environments. You can also write them in Python, TypeScript, Go, and Java, the AWS Lambdas. And the idea is to focus on your code. Don't think about the infrastructure. If your code needs to run concurrently in a concurrent manner 100 times, you don't care. You wrote one Lambda, and as many triggers as you get, depending on who triggers you, you'll get the amount of instances running at the same time. You only pay for what you use. So when it's not running, it doesn't incur any cost. And it's very good for event-driven kind of application. Something happened, wake up, do your processing, move it forward on your pipeline. And with AWS Lambda, once you have the AWS toolkit, it becomes very easy to develop. You can create them using templates. There are templates there for AWS Lambda and serverless. Serverless templates are more around the Lambda function and the overall environments, because they usually don't live alone just by themselves. There's something that will trigger it, and you probably need to do something with the information just processed, push it to a database, to another Lambda, to a queue, or whatever. Also with .NET, we have a framework built on top of AWS Lambda that looks and behaves exactly like ASP.NET Core, which means that you get to write controllers, and those will be invoked according to how you wrote the path in the code, and it uses configuration login just like .NET Core, just running on top of a serverless infrastructure, which means when someone calls your controller, it will wake up, perform operations, go down. You can develop easily with Lambda. A relatively new tool called Lambda Test. If you install AWS Toolkit or just go to GitHub and get the Lambda testing tool, you can run the Lambda function locally on your from Visual Studio, pressing F5. And you can deploy them automatically to the AWS Cloud. And you can run in AWS from Visual Studio, get a nice window, so you don't need to go to the console and do the same. Let's see that. So here in my code, going down, I have a Lambda function. You can see the using in the beginning for all the things that Lambda function is going to do. That Lambda function essentially is waiting for a new file to be stored on S3. Once a new file is created, it will wake up, read the information from that file, store it in a message, and send it to a queue. That's it. And the class name, up to you. It has the two clients I need, and the function code, after moving through all the constructor, is taking the new event and reading the new file that was created. I'll get a response. That response has a stream. The AWS SDK was created by .NET developers, and you can see that, because everything is exactly where you expect it to be. If you read in a file, it should be a stream. You don't really care if it reads it one chunk, one by one, all the file at once. That's not your problem. And I'll create a stream reader, read the message, and send the message to a queue. So roughly, removing all the try, catch, login, and so forth, I have here roughly 6 lines of code that takes something saved in a file, and then the information pushed to a queue. And that's it. And that Lambda function on AWS can be found under here. This is what it looks in AWS. It's a Lambda function. It has an S3 trigger. It has a queue and a bunch of properties I can set afterwards. Configuration values, alias, monitoring, and so on. But it's already there. And that Lambda function already ran, by the way, because it was up here and I stored the file, if you remember. So basically, I've created something that looks like this. Slightly useful workflow. Someone opens the task service. That task service will create a file in an S3 bucket. That file will trigger Lambda that will put that in a queue, and that queue will wake up a queue listener, that console application from the beginning to read that file. In fact, if I'll debug it, we can probably see the message I've just stored in. Okay. Now this is going to the cloud and back with a very bad internet connection. Think how fast it will be on your actual environment. Or how fast it will be if it will run in AWS. Now, when running .NET, I usually don't run them for my development machine. Those services need a home, somewhere to run. It can be a virtual machine. EC2 is Amazon Elastic Computing Cloud. I said Elastic of simple, so this is Elastic. And there's Elastic Beanstalk. Both of them will create virtual machines that you can use to host websites or your workloads. But these days we work with containers. And containers in Amazon can be hosted in Elastic Container Service, that's Amazon Container Orchestration, or Kubernetes. You can also, both of them can use virtual machines or Fargate. Fargate is serverless for containers. It's you just specify the type of runner you need for your specific task or pod, and Amazon will manage auto-scaling and provisioning of those resources. There's also AppRunner. AppRunner is basically, here's my code, here's my Docker, just run it on the cloud, and AWS Lambda. Now, if you're writing .NET Framework, and I guess no one in this room does that, then you're using Windows, then those services are available to you. On the other hand, if you're using .NET, the latest and greatest, then you can choose each and every one of them depending on your workload. You need a virtual machine for some reason, you can use a virtual machine, either managed or unmanaged offering, or you're using Docker, then you can use one of the 4 Docker options, or AWS Lambda if you write in serverless cloud native. How much? Okay. Now that's for new application, and I'm sorry I'm rushing through it. 40 minutes is less than I expected. We do have .NET modernization tools. Now, a thing to say about that. If you are writing in Java, some of the tools are not available to you because we've created them just for .NET. And those modernization tools are geared towards existing applications, from relatively old to very, very old applications. The first one is called App2Container. AWS App2Container will take a running website or Windows service and will containerize it in Windows Container. It can do that with .NET Core, but with .NET you just right-click Visual Studio, add Docker support, usually. App2Container can work on legacy application even if you don't have your source control code. It will take your website, it will extract all of the data, it will find out configuration, additional services, open ports, configure those into a Docker file, take out the files needed for that website or service to run, and build the instruction you need in order to deploy that in AWS. Other than that, we have .NET Porting Assistant if you need to move from .NET Framework to .NET Core. And the tool I show you briefly, which is called Microservice Extractor, which takes a monolith, map the different calls, the different dependencies inside that monolith, enable you to group either automatically using AI or by hand all of the different responsibilities and extract them to different .NET services while updating your existing monolith. And finally, there's something you can try called .NET Toolkit for .NET refactoring. That's the newest tool. It's a .NET extension you install on Visual Studio, and it will offer you refactoring and deployment options based on your code as you write your code, or as you deploy, or as you manage your code. Now, let's see Microservice Extractor for a minute. This is Microservice Extractor. Here I run it on a relatively small application, but even with a bigger one, it will find the different namespaces, the different calls between them. We're talking about method calls. And then I can go in, for example, this is models, which is less interesting than actual logic, which I hope to find inside services. And here I can see I have 3 things called services. I can press one of them, right-click it, and see the different calls in and out of that class service. And I can see whether or not it's a good candidate to extract. If I want to extract it, then all I need to do is go back to it and say, add node to group, and create a new group and call it inventory. Choose a nice color, add that, and now that group, which I can watch and see the details, that group has all of those services because they are needed by that specific class I just chose, and I can press extract and port group, extract group, and so on. And then I get to choose the target and the different nodes and whether or not they're compatible moving to .NET Core or .NET from .NET Framework. And then when I press extract, 2 different, in the first time at least, 2 different project solutions will be created, one for the old one minus this code, and one for the new service I've just created. Now, also enable me, let's see if I can find it, to run AI to do that for me. And then I can go and check whether or not it's correct. Here I run it because it does take a few minutes. And he found 5 different groups I can extract. Some of them correct, some of them not so much. Some of them are more UI oriented, which I probably don't need. And some of them are more logic oriented. And all of them with a different class I need to use. So where to go from here? There's a bunch of links, a lot of information. Like myself, there's quite a few architects in AWS specialize in Microsoft. We write in the .NET blog and in the Microsoft blog. And other than that, you'll find a lot of information here, tools, libraries, examples, and so on that you can read and try out. And install the AWS Toolkit and get started. I guess that's all the time we have for today. So if you have any questions, just come to me afterwards.
Okay, but before, bravo.
Thank you.